15 years ago today, the worst single city tornado disaster in recent American history unfolded in Joplin, Missouri, when a catastrophic EF5 tornado destroyed thousands of homes, businesses, and structures in southern Joplin. 158 lives were gone, making it the first tornado in U.S. history to kill more than 100 people since 1953. What meteorologically led to the most catastrophic tornado in recent American history? In this video, we're going to find out. May 22nd, 2011 was always not the most classic of setups. In fact, it was quite different, especially when compared to a setup like May 3rd, 1999. The main reason why is that the dry line was oriented northeast to southwest. Usually, in a more classic dry line setup like May 3rd, 1999, the dry line is oriented north to south. Having a northeast to southwest dry line is a negative for tornado potential because usually it always means messier storm initiation. Storms do not initiate cleanly and become discrete, but rather they struggle with outflow and they can be quite disorganized. Because of this, the SPC actually only put Joplin in a 10% tornado risk and left the 15% hatch risk further up, where the dry line was oriented more north to south or northwest to southeast. However, the atmosphere over Joplin was incredibly volatile. Tons of instability, warm, humid, angry, unstable, rising air was present over southwestern Missouri that afternoon. A CAPE value of 5,301 kilograms was present, or an estimated 5,000. That is an extremely high value. For example, when comparing it with the April 27th tornadoes, the Smithville and Hackleburg tornadoes only had access to about 2,500 CAPE. Even the Greenfield, Iowa EF4 from 2 years ago only had about 4,000 CAPE based on mesoanalysis. This event had 5,000. When you have that much CAPE, your updrafts, your supercellular updrafts become so strong that they can overcome lesser amounts of shear. There was good wind shear here present on this day, which is the change in wind direction with height. You can see how the winds change from west to south as you go towards the surface. That change in wind direction is important for tornadoes. But even though it wasn't as strong on May 22nd, 2011, the extreme instability more than made up for it. This will be incredibly important later on. Storms first formed along the dry line, and as you can see, because of the northeast to southwest orientation, they were quite messy at first. This doesn't exactly look like your bona fide supercell. But as time went on, the storms remained disorganized, but if you look to the south, you'll notice some showers popping up near Chetopa, Kansas, and getting agitated. These showers would become incredibly important and would become the entire basis for the Joplin tornadoes formation. You can see here how these showers get quite strong as they merge into the main storm complex, but things still look quite disorganized. However, these mergers would actually prove to be key. The updraft that produced the Joplin tornado began near Commerce, Oklahoma at about 21:45 UTC. It's this group of showers right here. But it didn't exactly change things in a hurry. Just 15 minutes later, while the updraft that would produce the tornado was gaining strength, the picture looks very disorganized. You have a storm with a hook echo here, but it is quite disorganized, and you can see 5 different updrafts. 1, 2, 3, 4, 5 in this mess of convection. No one updraft is winning, and because everything is so messy, none of the updrafts can fully take advantage of the extreme instability and power aloft in the atmosphere. However, that would change with a very important process called a merger. First, you can see that these two storms congeal into one supercell. And when two storms congeal into one, they make each other stronger and make the updraft, which is the rotating upward column of air that sustains a supercell, significantly stronger. And the supercell becomes stronger, and as you can see, that's exactly what happened. That first merger made this supercell dominant, and you can see the convection to the north and to the west begin to weaken as they enter the stable cold pool of this new dominating supercell. And you can see how the convection to the north and west weaken and become less organized. However, the storm that would produce the Joplin tornado was quickly becoming stronger and quickly intensifying. As it passed over Baxter Springs, it rapidly became strong, and in fact, merged again with the new supercell that had just formed from the first merger. This second merger, which had involved two storms that were much, much stronger. You can see how strong the Joplin storm is by this point and how strong the recently formed merger supercell is. When you combine two storms that strong into one, they become incredibly powerful. Look at how powerful that storm is. This also results in an incredibly important process for tornado formation. Each individual supercell has its own boundary, or basically an area that tries to suck up horizontal vorticity up into the atmosphere. What on earth is horizontal vorticity? Think of horizontal vorticity as horizontally oriented columns of spitting air. A storm's goal, in order to produce a tornado, a storm has to take those horizontal columns of air and turn them vertical. However, when two supercells emerge, their boundaries congeal into one. This process creates an exorbitant amount, a very large amount of new, much stronger, and more effective horizontal columns of rotating air. So not only did the merger make both storms stronger, it also created so much more horizontally rotating air for the new, powerful supercell to ingest. It is also important to note that not all mergers are favorable. There is a reason why you do not see tornadoes this strong happen all the time. For a merger to be favorable, it has to occur at the perfect spot. What do I mean by this? Look at this. This strong storm forms near Oswego and becomes supercellular, but as it crashes into the northern area, it doesn't really do anything and begins to kind of, dissolve and lose its identity. Why? This merger is happening in the wrong place. It is west of the main storm and is thus entering the stable wake of the new dominant supercell. Most mergers are not favorable and do not happen properly. This one was different. It happened at the perfect spot. Another more niche reason why not all mergers are favorable is because sometimes if you have an ongoing tornado or an ongoing mesocyclone, a merger can actually be quite disruptive. Basically, if a storm with a tornado gets a merger from the south, that merger actually distracts the tornado in order to get the horizontal rotating columns of air vertical as quickly as possible. You need the new storm that the merger's happening with to not have a mesocyclone, and that was exactly the case here. As these two storms emerged, they didn't really have a defined mesocyclone. You can see by the time that they've congealed into one incredibly powerful supercell. Not only have they taken over the warm sector undisputedly, you can see all the storms to the west are dying, and this is now the main lead storm, which has access to all the incredibly unstable air. When that happens, and then you see how the new storm does not yet have an obvious mesocyclone, that allowed, with help from the merger, it to take all of those horizontal columns of air and suck them directly vertically. If you have a mesocyclone already, the horizontal columns have to work around the mesocyclone. If you don't, they go directly vertical. And in an environment with this much unstable air, they go vertical extremely quickly. And this began to go vertical, and the mesocyclone developed extremely quickly right as the tornado approached Joplin. And tragically, this merger process directly led to the tornado hitting Joplin, Missouri. Out of everywhere it could have been, it happened to be directly on track for Joplin. The Joplin tornado was the result of an extremely unstable atmosphere and a series of mergers finally letting one dominant supercell take over and take advantage of the extremely unstable environment. You do not see this every day because such favorable mergers are very rare, and there were a few major things that went right. To summarize, the storm did not have a mesocyclone when it first formed, and second, the mergers happened in the correct area. And the mergers happened in a way that just happened to create an undisturbed, major, dominant supercell and let it take full advantage of the extremely unstable environment. Usually, this doesn't happen, and mergers can be destructive. But everything that could have possibly gone right here went right. Thank you for watching.